So we know the sine function looks something like this. Now, there are things called inverse functions, but like we did with the quadratic, you had to restrict the domain. Now, there's lots of different places you could do it. One of them, and what we're going to do is we're going to go from -2 over pi to pi over 2, because that's going to give us our smallest value of -1 to our largest value of -2. So we're going to restrict it to that region right there, so I don't need the rest of the graph now. Now, we know the inverse function is symmetric around y equals x, which is that line right there. And so if I were to graph these points right here and just move along that graph, I could actually calculate the inverse function. So where that b is right there. So if I graph that in, you can see that that's the inverse function for the sine. Sometimes we call it arc sine, sometimes we use sine to the -1. Periodic, so we have to restrict it. Now, where we restrict it this time, what we're going to need to do is start at 0 and go to pi. We can't use the other direction because you can see that in the negative direction it's not going to be 1 to 1. So if I restrict it to that region, then I can have an inverse. So now if I do like I did before and connect the point opposite, I can see that I'm going to get, that would be where the, because now it's 1 to 1, I'm going to get something that looks like this. And so if I graph where that b point goes, I get the inverse cosine function like that. So if I want to find the inverse of this function, I need to just pick one of those, because they're really, each one is 1 to 1. So all I have to do is find two asymptotes that I want to be stuck between. So let's pick them at pi over 2, minus pi over 2 to pi over 2, and then I don't really need the rest of the function. So I can get rid of that, and I will just use that one. Now when I take the line y equals x, right, we know that the inverse is symmetric around it. Well, if I take vertical asymptotes, what I'm going to get is horizontal asymptotes. So if you can see in the light blue there, you're going to get the horizontal asymptotes. Now if I connect a point on the tangent with a point on its inverse, I can see that as I move it, it's going to move along something like that. So I can see that I'm creating an inverse function that has these asymptotes. So if I put that in there now, there's my arctangent, and you can see that I have horizontal asymptotes going each way, and I get the tangent inverse. And I can actually see the segment that I built, that they separate like that, and then they get close together at 0, and then they go off, you know. So we have our inverse tangent function in blue. For the following exercises, find the exact value of the expression in terms of x with the help of the reference angle. Why do functions sine inverse of x and cosine inverse have different ranges? Well, because we need to restrict the domain of the sine and the cosine so that the functions are 1 to 1, we have to do it in different places because they aren't 1 to 1 in the same location. So the sine, as you can see here, we restrict it from minus pi over 2 to pi over 2, and we use this fourth quadrant going in the negative direction like this. This would be negative, so it's clockwise orientation, and we use this one going positive. So we're in these two quadrants, where the cosine we use the first and the second quadrants because that's where we're 1 to 1. So we're using actually the first quadrant and the second quadrant because we're only going one direction here like this. Since the functions y equals cosine and y equals cosine inverse are inverse functions, why is it that the cosine inverse of minus pi over 6 is not equal to minus pi over 6? Because it's not in the region in which we're defined. If I go to minus pi over 6, I would be down here, and since the cosine is positive there, that means it has the same value as the cosine here, so that means that the inverse of this thing would just be pi over 6. That angle right there, because I'm moving it into the quadrant. So I take the value of this thing, and I get what pi over 6 for the cosine is square root of 3 over 2. And so this would be square root of 3 over 2 as well. So I plug that in, and then the inverse would not give me minus pi over 6, but positive pi over 6. Why must the domain of the sine function be restricted to minus pi over 2 for the inverse function to exist? Well, we already said that is they need to be 1 to 1, and since this is periodic, we know they go up and down. We do have to chop it off so that we get all the way from 1 to minus 1. Now, now the word must is a little bit of a, you got to be careful with that. Why must it be that? It doesn't must be that. It doesn't have to be that. It actually can be any interval on which you get it 1 to 1, and you get all the values from minus 1 here to 1 there. It's just that then now you'd put the inverse into a different quadrant. We like to keep it around 0. Discuss why the statement is incorrect. Arc cosine of sine of x for all x. Well, because we have to restrict the domain, then that means that we can't use we're not going to get all of x when we do the inverse of the cosine. We can take the cosine of any angle, but the arc cosine is only going to give us values that come back to in this region right here from 0 to pi over 2. Most calculators do not have a key to evaluate secant inverse of 2. Explain how this can be done using cosine function or the inverse cosine function. Well, if we take theta is equal to secant inverse of x, because all inverse functions are really angles, then that would mean that the secant of theta has to be equal to x. But we know if we take the reciprocal of both sides, we would get the cosine is equal to 1 over x. Now we can take the cosine inverse of 1 over x and get, this would be the same, this would be our theta right here, right? That would be our theta. So these two would end up being the same thing. So if I want to find the secant of 2, all I have to do is find the cosine inverse of 1/2. For the following exercises, find the exact value if possible without a calculator. If it is not possible, explain why. Alright, let's try sine inverse sine of 5 pi over 6. Now, the sine is only defined, because we defined the inverse, right, in the first quadrant and the fourth quadrant. So in other words, it's only defined in these two quadrants right here. But 5 pi over 6 is over in this direction. Now, 5 pi over 6 is positive, and it has a reference angle of pi over 6, so essentially it's the same as this angle right here. And so that would mean that the sine inverse of sine of pi over 6, which is now actually in the domain of the sine function, and we would just get pi over 6 like that. Alright, let's try this one. Sine inverse of cosine of minus pi over 2. Well, the cosine of minus pi over 2 is here, which is 0. Sine inverse of 0 would just be 0, because that's where the sine is equal to 0. Alright, one more. Sine of tangent inverse of 4 pi over 3. Now this one's a little different because notice they swapped. So this is actually an angle. So we could write this as theta is equal to the tangent inverse of 4/3, which would mean that tangent of theta is 4/3. Now, put this in a triangle. Here's theta. This is opposite over adjacent, so this would make the other side, let's call it h because I'm running out of space here, square root of 16 plus 9, 4 squared plus 3 squared, which is 25, which is 5. So in other words, the tangent, or sorry, the sine of the tangent inverse of 4/3 is equal to opposite over hypotenuse, which would be 4/5. For the following exercises, find the exact value of the expression in terms of x with the help of the reference angle. Alright, so let's do this one. The sine of the cosine inverse of x minus, or let's do this one. The sine cosine inverse of 1 minus x. Again, this is an angle, right? Inverses are angles, so I can go theta is equal to cosine inverse of 1 minus x. So I mean the cosine of theta is 1 minus x, which is, on a triangle, opposite, or I mean adjacent over hypotenuse. So that means we need to figure out this side. So this side would be hypotenuse squared minus this side squared. So what would that simplify to? That would be 1 minus 2x plus x squared. Distribute the minus, so we get 1 minus 1 plus 2x minus x squared. Those cancel out. So I get 2x minus x squared. So then my sine would be opposite, which is this thing. So the sine of the cosine inverse of 1 minus x is opposite, which is this piece, 2x minus x squared over 1, which is just that. And we have our sine. Alright, so let's do 41. Tangent of sine inverse x plus 1 over 2 like this. Well, we do know that this is an angle, so we could say that theta is equal to the sine inverse of x plus 1 over 2. So I mean that the sine of theta is equal to x plus 1/2, which I guess we could write this as, get a common denominator, right? 2x plus 1 over 2. So that's our sine. So then if we want to know angle theta here is the opposite, right, over the adjacent. So that would mean that this side here, the other side, is going to be Pythagorean theorem. So it would be the hypotenuse squared, 4, minus this side squared, 2x plus 1 squared, which is 4 minus 4x squared minus 4x minus 1, which simplifies to 3 minus 4x squared minus 4x. Alright, so if I want to do the tangent of theta, which is the tangent of sine inverse of x plus 1/2, this would be opposite over adjacent. Let's flip those two around. And we have our answer there. Alright, so let's try 54. Suppose that you drive 0.6 miles on a road so that the vertical distance changes from 0 to 150 feet. What is the angle of elevation of the road? 0.6 miles, and the elevation changes from 1 to 150 feet. Now the first thing you probably want to do is convert this into feet or miles. So let's convert this into feet. So I have miles, right? And I would like feet there. So for every 5,280 feet, we get 1 mile. The miles divide off, so we get 0.6 times 5280, which equals 0.6 times 5280, 3168. Alright, so now we want to find the angle. So this would be tan inverse of opposite over adjacent. So again, we can just do that on our calculator. Tangent inverse of 150 divided by 3168. So that gives us the radians. Now if we want to put this in degrees, of course we would have to multiply that by 180 divided by pi, right? So we get 2.7 degrees. We round it off. Approximate, without using your calculator, arctangent of 10,000. Now, what we know is that we have these two horizontal asymptotes at pi over 2 and minus pi over 2. And we know at 0, it goes up like this and gets this sort of thing. Now, if I go out to 10,000, which is way out here somewhere, right, what I know then is that we're pretty close to pi over 2. So this is approximately pi over 2 because it's close to the asymptote. Suppose that a 15-foot ladder leans against the side of a house so that the angle of elevation of the ladder is 42 degrees. How far is the foot of the ladder from the side of the house? Well, we know that this is a 15-foot ladder, and we know that it's 42 degrees. How far is the foot of the ladder from the side of the house? So in other words, we want to find this value here. So what I know then is that if I take the adjacent over the hypotenuse, that would be the cosine of 42 degrees is equal to x over 15. So we get x is equal to 15 cosine 42 degrees. So now we just have to plug this in the calc. 15 times cosine of 42 angle degrees. We get 11.147 feet.